Section 9.1, problem 5, can a low barometer reading be used to predict maximum wind speed of an approaching tropical cyclone? For a random sample of tropical cyclones, let X be the lowest pressure as a cyclone approaches, and let Y be the maximum wind speed. All right, so here's our X's, here's our Y's. Now make a scatter diagram. Okay, so it's going to be one of these. All right, now let's just get a feel for this. Look, what we have is when X, the horizontal, is 1,004, Y is 40. Now look at this X right here. 1,004, oh, that looks like it could be a 40. Just pick another one, though. At 975, we're at 100. Okay, so come over to 975. Maybe that's here. We're at 100. Looks like it's good. Okay, let's just take the last one. 920, we're at 150. 920, we're at 150. You know, I think this one's it. Let's just run a quick check on the others. Now, in this one over here, when we're at, I'm going to do that ordered pair, 1,004 and 40. If I come over to 1,000, wait a minute, 1,004, that's even the wrong axis. Right, this is the wrong axis, right? What is this? This is the lowest pressure, and X is what? They tell us what X is up here. X is the lowest pressure. So the lowest pressure appears on the horizontal axis, and they've got theirs written on this vertical axis for this graph right here. That one's out. Now, what about this graph down here? All right, let's check the 10, well, it's the same problem here, right? What is this axis? This is the y-axis, and that is the maximum wind speed. But it tells us y is the maximum wind speed, and that should be our x-axis. All right, so, right, that should be x. So it's got to be this one or this one. Now, what is this one? Here's our 1040. At 1040, we're way up here in the hundreds, not at 40, right? At 1,004, we're not at 40, right? This one, at 1,004, we're way up here. All right, so that one's out too. So this is going to be our choice right here. Now, part B says, would you say the correlation is low, moderate, or strong? All right, so look, do these points lie pretty close to a straight line? You know, this is a judgment call. I don't think it's low. Could be moderate or strong. You know, I'm going to go with strong. It looks pretty close to a straight line to me. And then, oh, down here, would you say the correlation is positive or negative? Well, this is, if you draw a line here, that line has negative slope. So this is a negative correlation. As the barometer reading increases, the wind speed decreases, right? That's what's happening. As the barometer goes up, the wind speed goes down. Now here's the rest of the problem. It was just too big to get all on one page and still have it somewhat readable. What we're supposed to do here is use a calculator to verify, okay, let's verify all these computations. Let's use our calculator. So here's what we'll do. Let's go to stat. We're going to put these numbers into our calculator and have it compute for us. So stat over to edit. Edit because we're editing, right? We're putting numbers in. So stat edit. Your lists come up. Now you may have data in there from the last time we used this. Maybe there's data in here. Get your cursor into this list. So use your arrow keys, get your cursor here. And then use the up arrow key, get the cursor right on the L1 so L1 is highlighted. Get the cursor on L1 and press enter. It highlights that L1. Now press clear on the right column and then enter. And all that data disappears. Now arrow over to L2, so your cursor's here, up arrow to L1, to L2, all right, press enter to highlight the L2, and then clear and enter. And all that data disappears. Now, let's type this in. All right, so I'll go down the L1 column. Get your cursor in L1. Let's go with 1,004, 975, 992, 935, 987, and 920. Now at the bottom of my list, list 1, it is saying L1 with a 7. That means it's expecting the 7th piece of data, which means we should have 6 pieces in. And if you count them, 1, 2, 3, 4, 5, 6, and what, 1, 2, 3, 4, 5, 6, yes. Okay, and there are 6 pieces of data if you look back at your table. Now arrow over to list 2, and I'll read these numbers off for you. It's 40, maybe I can actually write it. It's 40, 100, 65, 145, 78, and 150. Now we'll do something we haven't done before. We're going to go back to the stat key, and we're going to go to calculate, and this time we're going to select item 2, which is 2 variable statistics. But we have 2 variables this time, not just 1 variable, we have 2. So we're going to do 2 variable stats. So go ahead and select that one. Now when you do, not much comes up, but here's what it says. X1 list, or X list. What is your X list? What is your Y list? And the frequency list. And then calculate. So our X list, that's coming from L1, right? That was our L1. So you need L1. Now how do you get that L1? You press second and the numerical key 1, because right above the 1 is the L1. All right, so press L1, enter. Go get L2 for the Y list. Same thing, press second, numerical key 2. Now the frequency list, if there's anything in it, just press delete. Press the delete key and get it blank. You just want that blank. And then go down and calculate. Press enter. Now a whole lot of stuff comes up with even an arrow saying there's more stuff down at the bottom. Now look carefully. You might have to scroll down. You probably will. All right, but it says, here's our problem. I'm following it up to the table here. Use the calculator to verify that the sum of the x's is 5813. All right, now that should be on your second line. The second line here, well, the first line says x bar. What's the average of the x's? 968.83. Then it says, here's the sum of the x's. So if you add up the x's, you get 5813. Okay, so we just have to verify all these. So you can verify the x squareds. So just look at your list, make sure your list corresponds to these numbers. This question asks us to compute R, and that's really what this section is all about, coefficient of correlation. Here's how we're going to get it. We're going to go back to stat. So let's go to stat. And then we're going to go over to tests. And we're going to go all the way down to F. Now you can scroll down, or actually you scroll up, it goes faster. But you want item F, and item F says linear regression t-test. So select that one. So either scroll down and press enter, or just, you have to scroll down and press enter. Now, what comes up is this. X list. We probably already have that from the last time we put that list in, right? So that's L1. Our Y list, that's L2. Frequency, each number that we put in, we're putting it in only once. Then it gives us this, beta and rho. Now we'll test that in momentarily. But then it says, what do we have? We have not equal to 0, less than 0, greater than 0. Then it says regression equation. We can just leave that blank. Then it says calculate. All right, so let's calculate. Get all that information in. Now, we're going to select one. We have, it turns out, we might as well say it right now. This row, what we're testing is this. H0 states that rho right? This is a Greek letter rho, R-H-O, is 0. That means that there is no correlation. Remember we said that when we let English letters be sample statistics. English letters are what we represent numbers that are computed from a data set. The Greek letter, that's the entire population, the number that represents the entire population. So since R, this is the coefficient of correlation, right? That comes from a sample, right? That comes from a sample. That's what we're trying to compute right now. Well, the corresponding parameter is rho. It starts with R. So that's why I think that's why we chose it. Now, what we're testing here is that we have a negative correlation. So we're going to say that the coefficient is negative. So that's what we want to test. So run your cursor over to the less than, and then go to calculate. All right, so we want less than. And now calculate. Now when you calculate, lots of things come up. Y, it just says Y. I like to write Y hat because it's our estimated Y value. It will be of this form, Y hat equals A plus BX. And then it says beta and rho less than 0, right? That's the one we're testing, that we have a negative correlation. It'll give us a T value. It's actually T star. It's negative 9.7, negative 9.727. Right, and then it gives us the P value. Now, it starts off like this. P equals 3.12. Now, that's bigger than 1. I know something's up. I know it can't be bigger than 1. So there's an E over here. So look for the E. It's negative 4. That means that P is equal to 3.12 times 10 to the negative 4. That's scientific notation. Scientific notation just moves decimal points around. So how do we get that decimal point there? We moved it 4 places. The negative says to the right. So to get it here, we went 4 to the right. So get it out. Go 4 to the left. So I'll go 1. I need 3 zeros. So the P value here is 0.0003. Okay? Now, keep scrolling down. It tells us degrees of freedom. 4. All right, it tells us A and B. A is, let me see if I can find it again here. A is 1340.88. What is that? 1340.88. All right, that's the A that goes here. What's B? What is that? B is negative 1.28. And then it tells me some other things. I got an S. The S is 9.94. Don't know that I need that. But then it gives me these. It gives me R squared and R. Finally, that's the R that we're looking for. Negative 0.9795. Negative 0.9795. That's the one we're looking for to answer our question. Long way to get there. So let's put that up here. Negative 9.97, but it says to round to 4 decimals. We got it. Negative 0.9795. 9795. Now, keep in mind, this R, I'll do it down here at the bottom. If I can draw it, R always goes, all right, this is R, it always goes between negative 1 and 1. There's 0. Now, if R is 0, that means no correlation, right? So there's no correlation in here. But if you're far enough from 0, you can say there's some correlation. Probably weak or low correlation here, low correlation, and then strong correlation out here. All right, so where are we? We're at negative 0.97, about 0.98, negative 0.98. You know, we're way out here. All right, so I'm thinking there is a strong negative correlation. Let's see if any of those selections are here. So given our value of R, we cannot draw any conclusions. No, we can. Our conclusion is a strong negative correlation. Given our value of R, y should tend to decrease as x increases. Yeah, that's true. Y is going to decrease. We can see that in our picture. Given our value of R, y should remain constant. No. Y should increase as x increases. No, the only thing that happens here is that y should decrease as x increases. That's going to be our answer right here. Now, that really finishes this problem, but look at all this information we've got. A lot of really good information. We might as well just finish this problem, although this is how it would actually go. Here's what we have. We really want to get an equation. Estimate y, a plus bx. So I have a, I have b. So y hat is equal to a, right? Here's a. All right, so that is 1340.88 plus b, well, b is negative, so how about minus 1.28x. Right, that is our regression equation. Or, if you want, line of best fit. Or, if you like, our prediction line. Because I'm going to predict y values from x. So here's what we're given. We're given an x, predict y. All right, now x for us, what was x? X was a barometer reading. Y was the wind speed. So given a barometer reading, we should be able to pretty accurately predict a wind speed, especially, but this is strong value of R, right? We have a big value of R here. And then while we're here, I'm just going to talk about this R squared. Just talk about this R squared. This is, all right, here's R. If you square it, what are we going to get? Oh, I didn't write that number. What is it? It is, R squared is 0.9594. Okay, so R squared is 0.9594. Here's what this R squared means. We'll talk about it a little bit in the next section, but R squared says this. If you look back at our model here, here's our model. There's some variability in our predicted value of y, right? If we're given a barometer reading, we put it in here. We're not going to get the exact wind speed. There's some variability here. All right, so we can account for 95 or almost 96. We can account for about 96% of that variability from our model. All right, so our model says that the wind speed is determined by the barometer reading, but we're off a little bit. So there's something else going on. What about that other 4%? Right? What about that other 4%? Well, maybe our model's not perfect. You know, maybe our data is not accurate enough. When we took our wind speeds and barometer readings, maybe we didn't get the exact values. Or maybe there's some other variable. Okay? There's some other variable. So it might be this. Now, if you look up at our equation here, this says that, the wind speed depends on the barometer reading, but just maybe it depends on something else. So it could be that, we could get a more accurate reading if we added in, something else. I don't know what that something else would be. I don't know. But some other variable. So that's the information that R squared gives us. So the higher value of R and R squared, the more accurate our model is going to be, the better predictor we'll get.